I welcome you all for the next tutorial about the next sorting technique, that is selection sort. Already we discussed about bubble sort and insertion sorting technique, and the third sorting technique we are going to discuss is selection sorting method, or we can say it is another kind of sorting technique. So in my point of view, the selection sorting algorithm is very simple to understand and it is very easy. Okay, so it is also an in-place comparison sort. Okay, so no extra space is needed, no extra memory space is needed. So that's why this algorithm, selection sort algorithm, is called as in-place comparison sort algorithm. Most of the some of the basic sorting techniques or in-place comparison sorting type of algorithms, bubble sort and insertion sort and this selection sort. Okay, so everything is an in-place comparison sorting technique, and it is a comparison sorting technique. So you have to compare the elements in order to sort the list. And this is also inefficient for larger set, like insertion sort algorithm. This is also applicable for small set. It is efficient only for the a small set, set of numbers. If the number of elements is greater, it is inefficient. Okay, inefficient for larger sets. Okay, and here the selection sort algorithm, it divides the list. Okay, we are having a list of items to be sorted, so that list, okay, is divided into, so this algorithm will divide that list into two parts, sorted and unsorted sublist, like insertion sort, but there is a difference. Okay, but there is a difference here. So in the insertion sort algorithm, we can say the list on the left hand side is called as the sorted list, and the list on the right hand side is called as unsorted list. Even though the list on the left hand side is called as sorted list, but it is actually not sorted. Okay, because when you think of, or when you go through the elements in the unsorted list, few more elements or less than the elements in the sorted list. Okay, so only that list is sorted, not the entire list is sorted. Okay, but here in selection sort algorithm, if we say that list is a sorted list, that is sorted. Okay, so it is in the correct position. Okay, so once it is in the right position, we won't change its position. Okay, so but it is not the same in insertion sorting technique. So this is the difference between, main difference between insertion and selection sort technique. Okay, so here the algorithm is going to divide the list into two parts. One is sorted list and the other one is unsorted list. Okay, so once the sorted list is ready, so that will not be touched. Okay, so once the element move to the sorted list, so it will be there in the list till the end. Okay, so till all the passes gets over, till the algorithm execution stops. Okay, so it will not change. Okay, initially sorted sublist is empty. Okay, so no element in the initial sorted list, but in the insertion sort, one element in the sorted sublist. Okay, you have to compare these two algorithms. Okay, and unsorted sublist is entire list of items. Okay, here in selection sorting technique, and here algorithm finds the smallest or largest element. It depends upon the sorting order. If you want ascending order list, you have to pick the smallest element. If you want descending order of your items, you have to pick the largest element. So algorithm finds the smallest or largest element. It depends upon the sorting order and exchanges accordingly. And the time complexity is same like bubble sort and insertion sort. Here also the time complexity is order of n squared. Okay, and very simple algorithm, selection sort algorithm. It takes two arguments like all other algorithms. So A and n. A is an array of n elements in unsorted order. Okay, and here we have used two loops. One indicates the outer loop indicates a sorted list. Okay, and the sorry, the outer loop, that I loop, it is used to refer the items, what item we are going to check. Okay, we have to check all the elements till n minus 2. For example, you are having n items, 5 items abdina, up to which we have to check. So from 0th element, that is first element, to n minus 2th element we have to check. Okay, and for each and every element, okay, that first element is compared with all other elements and second element is compared with all other elements. Okay, so for the remaining list, for the unsorted list, we are maintaining j. Okay, and you have to check I and j. If the I value is greater, means you have to swap. We'll see the example. Once again, we'll come back to the algorithm so that you will understand. So this is about the selection sort execution and the working of selection sort algorithm. If it is ascending order, for ascending order, you have to find the minimum element. Okay, minimum element and place at position 0. So this is the first step. So you have to find the minimum element and you have to place at position 0. If you are going to do descending order, sort the elements in descending order, you have to find the maximum elements, maximum element. Okay, so this is the difference between the ordering. Okay, so ascending order means you have to pick the minimum element. If it is descending order, you have to pick the maximum element and you have to, sorry, I have done wrongly, so place at position 0. If it is minimum or maximum, you are going to place it 0th position. Okay, here we are going to consider the ascending order. Always we'll sort in ascending order, right? So that we are going to take. So in pass 1, okay, so the entire list, here we are having an array of size n, 5 elements. Okay, so all 5 elements are unsorted. Okay, so initially sorted list is empty. Okay, so first we have to pick the first element. Okay, so I equal to 0. So the remaining elements are, what are the remaining elements? From 1 to n minus 1. So these are the remaining elements, 25, 12, 22 and 11. Okay, so we are going to compare first element with the second element, first element with the third element, first element with the fourth element and first element with the fifth element. We are going to compare first element with all other elements. Okay, so after doing this process, so your first element will be the minimum element. Okay, so that element is sorted, placed at correct position. After each and every pass, one element will be placed at right position. So that is about the selection sorting technique. So here the first element is compared with second element. So 64 and 25 are compared. So first element is greater. So since we are doing ascending order sorting technique, so we have to swap these two elements. So after swapping, so 25, 64, 12, 22 and 11. Okay, then again you have to compare first element with the third element. So here in the first element, now we are having 25. So 25 is compared with 12. So again it is greater. So we have to swap those two elements. So now in the first position we are having 12 and in the third position we are having 25. Okay, so next we have to compare first element with the fourth element, 0 and 3, 0th position element and third position element will be compared. So 12 and 22 will be compared. So 12, the first position element, the element at position 0 is less. Okay, no need for swapping. Okay, first element are smaller, so no swapping is needed. Okay, next j is alone incremented, so I value is 0. Okay, because since it is the outer loop. Okay, so ஒரே ஒரு element எடுத்து எல்லா element ஓடையும் we are checking. Okay, so I value is same and j value we are moving from 1 to n minus 1. Here n value is 5, so up to 4. So first time j is 1, second time j is 2, j is 3, j is 4. Okay, it is compared with the ith element. So here I position is 0. So a of 0 and a of 4 are compared. Here this element 11 is less than the first element, so you have to move this element to the first position. So swapping is needed. So that's all. We have compared all the elements with the first element. Okay, so j elements, jth elements are compared with ith element. Okay, ith element. So after pass 1, So pass 1 is over. So now we have one element in the sorted list. Okay, so 11 is placed in the right position. Okay, so afterwards it is not necessary to check this 11 with all other elements. Already we have checked this element with all other elements, so this is the minimum element. Okay, so that's why we have placed this in this element in 0th position. So this is the sorted list and this is the unsorted list. 4 elements are in unsorted list. Okay, next in pass 2, so now we are having 4 elements, so you have to start from 1. 1 means second element. So second element is 64. Idoda position in the end element varunum kandupidikka porom. Okay, and the remaining elements are I plus 1 to n minus 1. Here I is 1, so I plus 1 is 2. 2 to n minus 1. So a of 1 is compared with 2, a of 1 is compared with a of 3, and a of 1 is compared with a of 4. Finally a of 1 contains the minimum, next minimum element. If swapping is needed, swapping is done. Finally we'll get the next minimum element in a of 1th position, index 1. So here after pass 2, so 2 elements are sorted, and likewise in pass 3 we have to take the third element. So third element is compared with fourth element, and third element is compared with fifth element. Okay, so finally after completing pass 3 we'll get the minimum element, next minimum element in position 2. Okay, then we are having 2 more elements. So pass 4 it compares third element and fourth element. Only 2 elements are in the unsorted list, so you have to check the elements. So swapping is needed. So once swapping is done, we'll get the sorted list. No more elements are in the array, so the process is over. So we'll get the final sorted list. So this is how the selection sorting algorithm it works. Okay, now look into the algorithm, you will understand. So I is 0 for 0th element. So 0th element is compared with first to n minus 1 element. Okay, if the ith element is greater than the jth element, so swapping is needed. If not, it moves on to the next element and it will compare. Then I is incremented and the remaining unsorted elements are compared with the ith element. Likewise it goes on. Okay, here also in pass 1 we need 4 comparisons. Okay, 4 comparisons are done in pass 1, and in pass 2 3 comparisons, and in pass 3 2 comparisons, and in pass 4 2 comparisons. It is similar to the insertion sorting techniques. So the time complexity is order of n squared. Okay, so this is about the selection sorting technique. So the exercise problem is given. You do the sorting with the list of numbers given with the help of this video tutorial. Right? Thank you, girls.